Good morning, fellow mathematicians, and welcome to what is possibly going to be the worst decision that I have ever made in my life. That is planning on completing 3 HSC exams back to back as quickly as possible. Now, I don't know about you guys, but this is actually going to be disgusting. I'm 110% not feeling it. But hey, you know what? We're going to get it done. We're going to get in there and get it done. So, if you are unsure about how this is going to work, well, firstly, either am I. Secondly, it's going to be, there's like a list of rules that I've sort of set myself. Basically, I can only do a certain amount of questions. Sorry, I can only skip a certain amount, I think 5 marks I set myself. I have to seriously attempt everything, which is another biggie. Here's the list of rules here. So I have to attempt everything in a serious manner. Can only skip a maximum of 10 marks per exam. And yeah, that's basically the main 2 rules. And I'm not going to do it as quickly as possible. So in the sense that I'm going to only skip 10 marks worth of questions is that if I actually get stuck on something, I'm going to skip it. But I'm going to seriously attempt everything in a manner that would try and get me over 50%.
Even with limited resources, I love being resourceful. But realize there's a lot of false imagery out there.
Anyway, I think with that being said, I think we're ready to start. What do you reckon? Are we ready?
I get disturbed when I see these press
Let's get this thing up.
Hello.
Hello. Alright. That's looking pretty minty. Try to get my speedrun frame to fit. Perfect. Okay, that makes it look a little bit better at least. So yeah, this is going to be something different, that's for sure. It's going to be the worst. Alright. So we've got the Mathematics 2 exam. Now, I'm not going to actually start looking at it, I'm just going to open this up and just talk about this for a sec. Firstly, there we go. Firstly, so I'm going to start with Mathematics Standard 2 and I'm going to work my way down. As you can see over here, I've got my timer up here. These are the time limits that you are given in the exam, so not the actual times it should take me to finish them. This video is more so going to be not an instructive video, more of just me doing them whilst I talk to the people in chat. And whilst I'm talking to myself if no one's talking in chat. Like, same diff. Regardless, we're going to start shortly. And yeah, get it done. So you'll notice I've included the reading time in these as well. I'm just going to skip the reading time myself and jump straight into them because it's a speed run. We wanted to try and finish it as quickly as we can. Anyway, without further ado, I think it must be time for us to start. So I think we're ready. I think that's everything I need to talk about.
Which of course it's problematic because it creates more pressure to create more things like that, right? When it's an accident.
Yeah, so
To realize that
I think it must be time to jump in. Alright, let's do it. So starting in 3. It's gonna be a long 8 hours. 2, 1. Alrighty. Ooh, that jumped quick. Okay, which of the following shapes have the largest perimeter? Dun, 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 dun. Hopefully my pen's working. Yeah, it looks like it is. Cool. Alright, so perimeter 8 by 4. What's that? 8, 16, 24, 32. Cool. 11 by 3 times 2, so it's going to be 14 by 2 equals 28. So currently the square, 10 by 3. Okay, plus the 4 there, so you got 9, 12, 16, 20. So it's A for that one. Easy. Let's get going. Consider the network diagram. What is the sum of the degrees of all the vertices in this network? Okay, that's degree 3. It's degree 4, degree 4, degree 3, degree 2, 4, 7, 10, 14, 16. Cool. Keep going. 7-leaf plot shows number of goals scored by team and each of the 10 netball games. What is the mode of this data set? So most common. So I see 2 5s here, so 25 is what that represents. 3 years ago, an appliance was valued at 2,467. Its value is depreciated. 3 years ago. So, so it's depreciating at the same rate. So it's going to be what? So the salvage price is going to be equal to the principal, which is 2,467, minus the rate, which is 15%, to the power of 3. Alright, I don't actually have a calculator on my screen, so that's fine. Don't want that. Don't want that, don't want that. We want this one. So what? 2, 4, 6, 7, 1 minus 0.15 to the power of 3. It's gonna be, we get 15.04, so the closest one is D. Cool. Alright, Peter concurrently earns $21.50 per hour. His hourly wage will increase to 21% compounded each year for the next 4 years. What will the hourly rate be after 4 years? So it's 2.1%, so as a decimal that's 0.021. So the formula would be his hourly rate, so the amount is equal to $21.50, 1 plus 0.021 to the power of 4. It's weird that they've got 2 compound questions like right after each other. So 1.021 to the power of 4. So B. So key word there is compounding. Suppose A is equal to this, where B is equal to 2. What is correct value of A correct to 3 significant figures? So A is just equal to 22 on 7. And we get a calculator out for that. 22 on 7, because 21 on 7 is like 3 exactly. It's 3.1428 blah blah blah, which is just 3.14 to 3 significant figures. So A, easy, let's get going. Number of download songs 20 consecutive days is shown in the following graph. Which of the following graph best shows the cumulative number of downloads are 2 including each day? Cumulative, so it speeds up and then slows down. It's gonna be this one here. So this one, it speeds up and then starts to slow down. So the total's getting smaller and smaller. Pretty simple. On a test, Zach's marks corresponds to z-score 2. The test had a mean of 63 and a standard deviation of 8. What is Zach's actual mark on a test? A z-score 2, so it's positive 2. So it's 2 standard deviations, so it's 16 above the mean. So 16 plus 63, 79. So the actual way you would do that is just 8 times 2 plus the mean. Yeah. Cool. Student is thinking of a number, let the number be x. When the student subtracts 8 from the number and multiplies the rest by 3, the answer is 2 more than x. What the hell? A student is taking thinking of a number, let the number be x. When the student subtracts 8 from this number and multiplies the result by 3, so x minus 8, and then multiplies that by 3, the answer is 2 more than x. So x plus 2. So which equation solves this? Okay, well that's easy. Let's see. Cool. Which of the following best represents the graph of y is equal to 10 times 0.8 to the power of x? It's going to be C. Oh, actually. So 0, so it's going to be 10. Yep, so it's C. The exponential graph starts at 10. Cool. There are 8 chocolates in a box. They have a peppermint center. Sorry, 3 have peppermint centers, 5 have caramel centers. Kim randomly chooses a chocolate from the box and eats it. Sam then randomly chooses and eats one of the following chocolates. A partially completed probability tree has been shown. What is the probability that Kim and Sam choose chocolates with different centers? Okay, so it's a non-replacement one, so it's going to be, so if she takes a peppermint out, it's going to be 2 out of 7, and then 5 out of 7, and then 3 out of 7, and 4 out of 7. Okay, what is the probability that Kim and Sam choose different colors? So that's this one and this one. So it's 3 out of 8 times 5 out of 7 plus 5 out of 8 times 3 out of 7. So those 2 columns there. So whatever that sum is, we don't want to do that. 3 out of 8 times 5 out of 7 plus 5 out of 8 times 3 out of 7. 15 out of 28. There it is. Cool. Okay, block of land represented by a shaded region and number plane. All measurements are in kilometers. Which of the following is the approximation for the area of the block of the land in square kilometers using 2 applications of the trapezoidal rule? Okay, so the height is 6, so it's going to be 6 on 2, 1.2 plus 2 plus 6 on 2, 1.2 plus, sorry, 2, I don't know how to get an eraser up on this one. Sorry. I think the hardest bit is going to be trying to control this with a mouse. Okay, so it's going to be 2 plus 1.4. And then just add those 2 together. So I'm just going to do the shortcut for that. So 6 on 2... 1.2 plus 2 times 2 plus 1.4. So it's 19.8. Oh, cool. Okay, the time taken to clean a warehouse varies inversely with the number of cleaners employed. It takes 8 cleaners to do 60 hours. Working at the same rate, how many hours would it take 10 cleaners to clean the same warehouse? So if it's inversely proportional, it's going to be this formula. So if we call this our x and that's our y, it's going to be 60 is equal to k on 8. So my k value in this case is going to be... Oh, is that right way? Yeah, it is. So 60 times 8. What's that? 6 times 8 is 48, so 480? Yeah. So 480. So my formula is y is equal to 480 on x. So y... So if we have 10 cleaners, so y is equal to 48, which is that one. Consider the diagram below. What is the true bearing of A from B? So A from B. So we're going back this direction. Okay, so draw up my thing. So if that's 25 degrees, in there's 25 degrees. So it's going to be, well, 90 times 3 plus 25 degrees. 90, 180, 270 plus 25 is equal to 295 degrees. A total of 11,400 people entered a running race. The ratio of professional runners to amateurs was 3 to 16. All the professional runners completed the race, while 600 of the amateurs did not complete the race. For those who completed the race, what is the ratio in simplest form of professional runners to... Jeez, this is a mouthful. A total of 11,400 people entered a running race. The ratio of professional runners to amateurs was 3 to 6... 160. Sorry, 3 to 16. So if there's 19 in total, which equates to 11,400. So 1's going to equate to... So 1 ration, is equal to 600. So that means 3 is going to be equivalent to 1,800. Which means that 16 would be equivalent to 9,600. Okay, so all the professional runners completed the race, while 600 of the amateurs did not complete the race. For those who completed the race, what is the ratio in simplest form? So the amount of people that completed the race, I feel like I've gone about this a really, really robust way. Completed race, 11,400. Minus 600. Well, it's only 9,000 people, isn't it? For those who completed the race, what's the ratio in simplest form of professional runners? So it's going to be still 600 to, well, it's just 600 to 9,000, isn't it? Because 600, so it's just coming out of this number here. 1, 2, 3, 1, 2. So it's 6 to 90, which is the same as 3 to... 6 to 90. Same as 3 to 45. How many 3's in 45? 15. No. So 9,600 amateurs finished, which means that, sorry, 9,600 amateurs are in the race. 600 amateurs didn't finish, so it has got to be 9,000. So it's 600 to 9,000, which is 6 to 90. So what's the biggest ratio between 6 to 90? There's a way I can do it on this, I believe. Maybe not. Not on this one. Okay, I'll just do 90 divided by 6. 15, it is 15. I'm so confused. Because there's 1,800 runners and It's really weird. I don't know how else to do that. Physically race, what is the ratio in simplest form of professional runners to amateurs? Oh, it's not 600, it's 1800, that's why. It's 1800 to 9000. That makes a lot more sense, now that I think about it. So the real ratio is 18 to 90, which is 9 to 45, which is 1 to 5. Cool. Okay, that makes much more sense. Wait, is there only 15 multiple choice questions? That's weird. Cool. 3 blank pages. Alright, sentence number. Oops. Gotta put in the memes. Alright. The volume V of a sphere is given by this, where R is the radius of the sphere. 10 consists of the bottom half of the sphere. With radius 2 meters as shown. Find the volume of 10 cubic meters, correct to 1 decimal place. Really? Okay, volume is equal to 4 on 3 pi times 2 cubed. What, 2 cubed? To 1 decimal place, so it's 33.510 blah 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 blah. So it's just 33.5, and that's in meters cubed because it's volume. A lot of space for a very simple question. Am I missing? Oh, it's half of 1, and then so half, of course. So just half my answer from above. This is going to be 16.8 is what it ends up being. Okay. Almost looked very dumb for a moment then. No, classic half. Alright. The 5-number summary of data set is 20 an outlier. Justify your answer with calculations. So the formula for an outlier it is Q3 plus 1.5 times the interquartile range. So Q3 in this case is 10. So we're going to need to work out the interquartile range, which is 10 minus 4. So that's 6. So plug it into that, and then anything greater than this is an outlier. So 1.5 times 6 is 9, so 10 plus 9, which is equal to 19. So anything greater than 19 is an outlier. Therefore, 20 is an outlier. Cool. The fuel consumption for a car is 6.7 liters per 100 kilometer. On a road trip, the car travels a distance of 1,560 kilometers, and the fuel cost is $1.45 per liter. What is the total fuel cost for this car trip? Alright, well, we need to work out how many liters we've used. So liters used. So it's 6.7 liters per 100. So it's 1560 divided by 100 times 6.7. And this will give us how many litres are used in the trip, right? 1560 divided by 100 times 6.7. 104.52. Okay, then the cost is just going to be $1.45 times 104.52. So it's going to cost them $151.55. Easy peas. Alright, question 19. Adam purchased some office furniture 5 years ago, depreciated by 2300 each year based on the straight line method depreciation. The salvage value of the furniture is now $7,500. Find the initial cost of the furniture. So after 5 years. So if this is what it ends up at, it's going to be 2,300 times 5, and then you're going to add that on to 7,500 because that's what it's going to go up to. So it's now worth 7,500. So if we add on what it lost, then it's going to get back up. And because it's a straight line depreciation, we're just multiplying the thing. Fuel consumption question, baby brain easy, 110%. This exam is not... This is like the easiest level of exam you can do for maths in New South Wales. So yeah, that's how much it was worth after. Oh, okay, some stuff I haven't done in a while. Ugh. City A is in Sweden, is located at 58 degrees north, 16 degrees east, located at 151 degrees east. Robert lives in Sydney and needs to give an online presentation to his colleagues in City A at 5 p.m. Thursday local time in Sweden. What time and day in Sydney should Robert start his presentation? So he needs to do it at 5 on Thursday. Sweden, 151 east is further in the future, so you need to add it on. So the difference between 151 and 16 is equal to 631. And that doesn't look right. .35. It's one short. So 135. Given at 15 degrees is equal to 1 hour time difference. So time difference 135 divided by 15. Let's just do it on the calculator. So it's 9 hours times difference. And because Sweden in the past? No, it's in the future, isn't it? Let's just put it in inverted commas because it's not technically in the future, but it is. So he needs to start. Nine hours before it. So 5 p.m. So 5 p.m. is 1700 minus 0900, which would mean that he needs to start at 7, 8. On the same day. Oh, that was annoying. Alright, Julie invests 12, 50, 100 in a savings account. Interest is paid fixed monthly rate. At the end of the month, interest is added. Julie's deposit of $500. Julie has created a spreadsheet to show the activity in her savings account. The details of the first 6 months are shown. So the way that these things work is usually this by finding the monthly rate of interest. Okay, so we just need to work out what the percentage is from this to this. So what do we need to multiply this by to get to this? So in other words, the rate's going to be, and it doesn't matter which one of these we use. So if we just do the first one, 12,500 divided by 18.75. Maybe? Let me think how you'd work this out normally. So to work out the monthly interest, it's going to be P times 1 plus R to the power of N being 1 in this case, so... compound from, so A equals to P1 plus R. We know the amount at the end, we know the amount at the beginning. Okay, so we're gonna have to do it this way. So, get rid of this stuff. Okay, that's all I can get rid of apparently. Why can't I do anything? You're ruining my speed run, Mr. Computer. Okay. So. Oh, but that includes the extra 500 as well. Oh. Okay, so it's going to be whatever the sum of these two is. So 12, 5, 0, 518.75 over 12,500. So this is going to give me my rate here, okay? Because if you look at the formula, okay, so n's equal to 1, so that just gets rid of that. Okay, and it's going to give me my rate plus 1%. So it's equal to 1 plus R. And so R is equal to 1, or that minus 1. Yeah, this minus... Yeah, that minus 1. That makes sense. So 12, because the answer's going to be a bit over 1. So that minus 1. So it actually gives me 1.5 times 10 to the negative 3, which is the same as 0. I think it's right. 2, 3. So that is a decimal. Yeah, okay, and then the percentage would be 0.15%. Okay, so if this gives me a nice number that fits in the rest of this, so to work out 7 then it's going to be this number here. So 1, 5, 624.20, and I'm going to times that by 0.15. 624.20 times by 0.15. Percent, of course. Of course, can't forget the percentage. Yeah, cool. Okay, and that gives us 23.44. Okay. So then add the $500 onto that. So plus answer plus $500. And it's going to give us 16,147.64. Cool. Alright, the table shows income tax for the financial year. William is a gross annual salary of $8,400. He has allowable tax deductions of $900 for home office equipment and $474 for union fees. William must pay Medicare levy for 2% for his taxable income. Calculate the total tax payable by William, including Medicare levy. So his gross is so the amount of tax and 474. Okay, so his taxable income. $84,000 minus 900 minus 474. So his actual taxable income $82,626. Okay. So now we just need to look for which group that's in. That's in this group here. So tax payable is going to be equal to, so we just read this out, it's 5092 plus 0.325, so 32 and 5 cents as dollars is 0.325. And then it's going to be for each dollar over that amount, so it's 82626 minus 4,500. Okay, that's his taxable income. Okay, and then 2% of his taxable income as well. So 5092 plus 0.325. Lots of 82626 minus 45,000. So tax payable is 17320.45. Now his Medicare levy is 2% of this, so 82626. So 1% would be, so 1% is equal to 826.26 times by 2 for 2%. So it's going to be 1215 and 8 times 2 is 16. So 1652.52. Okay, so total tax to pay is equal to $17320.45 plus 1652.52. And I'm just going to add that on. get 18972.97. Cool, and then that should be the map. Yep, so that's including the Medicare levy. Cool, okay. Network diagram shows travel times in minutes along the roads connecting a number of different towns. Draw a minimum spanning tree for this network and determine its length. Okay, we'll start at Queentown. Okay, so the shortest connecting path is to Kingsville. And it takes 30. Okay, so now including both of these, which is the shortest, it's going to be to Minortown, which is 25. Okay, including these three, Minortown to Walttown is 10. Okay, and then Walttown to Parktown is the next. With 10. Okay, so I've done Queenstown, I've done Minortown, I've done Kingsville, I've done Walttown, I've done Parktown. So the next shortest distance, I think it's going to be either Minortown to Underwood or Walttown to Fernville. Let's go let's go Minortown to Underwood, because it connects the shortest. So Minortown to Underwood is 20. Like that. Okay, so that knocks that one out. And Walttown to Fernville also has 20. And finally, to get to Citadel, we're going to go via Parktown. And that was 40. So just to double check, 30, 25, 10, 20, 15, 20, 40. Cool. Okay, length of the minimum spanning tree, 30, 25, so 55, 75, 85, 95, 115, 155. Okay. How long does it take to travel from Queenstown to Underwood using the fastest route? The fastest route. So despite the fact that this is part of the minimum spanning tree, it's actually quicker to get to Minortown from Queenstown. So it's going to be the 45 along there. And then from 45, then you get to Underwood. Yeah? Queenstown to Underwood. So you're going to go along here. So again, you're not going to go this way or that way or anything, because it's just much quicker to go through there. So 20. So plus 20. So it's 65. Cool. Done. Population P is to be modeled using this formula, where T is the time in years. What is the initial population? So initial population is when T is equal to 0. So the initial population is going to be equal to 2000. 1.2, we'll do the working out as well. So 2000 times 1, which is equal to 2000. Find a population after 5 years. So T is equal to 5, P is equal to 2000. Lots of 1.2 to the power of 5. So the population is 1.2 to the power of 5. That gives us 4, 9, 7, 6. Now it's 76.64, which would then go to 4976 population. Because we haven't quite reached the next number yet. On the axis below, draw a graph of the population against time showing points at t is equal to 0 and t is equal to 5. Okay, so t is equal to 0. So this will be your t-axis, yep. And this is at 0. And this is going to be at 2,000. This is at 4,000. And we want to go up to 4,9. So at 5. It's going to be like this. And it's going to be a graph that looks something like this, because it's an exponential graph. Yeah? Something like that. That'll do. Alright, the rectangular sports ground has been drawn to scale on 1 centimeter grid as the scale is used is 1 to 3,000. Kerry took 12 minutes to walk around the perimeter. Oh, I forgot to add this point in. What number did we say? 4976 point. Oh, well, that'll do. Okay, a rectangular sports ground has been drawn to scale on a 1 centimeter grid as shown. The scale used is 1 to 3,000. Kerry took 12 minutes to walk around the perimeter of this. What is Kerry's average speed in kilometers per hour? Okay, so 1 to 3,000, and the scale is on a 1 centimeter grid. So each one of these is 3,000 centimeters, which is what, 3 meters? 100 centimeters makes a meter. So 30 meters. Hang on, let me get this right. 1,000 millimeters, yeah, so 100, so it's going to be 30. So each one of these represents 30. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 5 times 2. We probably should do this in the working out space. 8 plus 5 times 2 is equal to 26. So it's 26. Oh, well. So it's 20. The perimeter of that particular shape is 26. And then for each one of those, it represents 30. So each 1 centimeter represents 30 meters. So it's 26 times 30 meters, which is equal to big. So 780 meters. Now average speed, assuming she's not speeding up or slowing down and she's doing the constant speed all the way around, is 780 divided by 12, which is equal to something I could probably do in my head. $65. Now that's 65. We need it in kilometers per hour. So that's 65 meters per minute. So 65 meters per minute. So to do it in kilometers per hour. So we're going to change it to 6500. So 65 is 1,000 meters in a kilometer. So kilometers per minute, and then so times by 1,000, and then I'm going to divide it by 60, which seems way too big, but you know. Apparently she's running at 1,083 kilometers per hour, which to me seems like it's very wrong. So it feels like I've done something wrong. Especially considering she's only walking. Have I done something wrong up here? Let me just think. Let me go back to start. So, a rectangular sports ground has a scale of 1 centimeter. As shown. Here we are. So, each one of these centimeters represents 3,000 centimeters. 3,000 centimeters to meters is 30. So each one of these is 30 meters. So 30 meters for one of these Now, if the whole perimeter is equal to 26, and then you times it by 30 for 30 meters, you should have 780 meters. Cool. Now, 780 meters per minute. Oh, I times it, not divided it. Because you're going to a smaller unit, it's going to be divided by here. That makes a lot of sense. And hence why, when you're doing your HSC, you should always make sure to see if your answer makes sense. Because if it doesn't, then you've done something wrong. So 65 divided by 1,000 gives us, that looks a bit better, 0.065. So that's kilometers per minute. Now to change it from minutes to hours, we would normally divide it by 60, but because it's on the bottom of the fraction, we're going to times that by 60, I think. And that's going to give us, yes, 3.9. So 3.9 kilometers per hour, which makes so much more sense. So the reason we times that by 60, so if you think about it, 65 minutes per, or meters it should be, per 12 minutes, or per 1 minute. Okay, so you times the top by, well, you divide the top, sorry, because we're going to a big unit, you divide the top by 1,000, and divide the bottom by 60 to change it to 65 divided by 1,000 kilometers over 1 divided by 60 hours. And then, yeah, just work out that. So 65 divided by 1,000 over 1 divided by 60, which is the same as, yeah, whatever. Don't need to explain it. I'm doing speedrun. Speedrun. Slowing me down explaining it. Okay, you need to invest $35,000 for 1 year. She is offered 2 different investment options. Interest is paid at 6% per annum, compounded monthly. Calculate the future value of Nina's investment after 1 year if she chooses option A. Okay, we'll just start with that one first, and then we'll worry about option B after. So 6% compounded monthly, so it's going to be 12 months. And 6% per annum, so it's going to be 6% divided by 12, which gives me 0.05%. No, 0.5% per month. Okay, so using the compound interest formula, well, the future value formula doesn't really matter. We can do the future value. So future value is equal to the present value, 1 plus. Okay, so my rate to the power of n. So my future value we don't know yet, so we're trying to work out. My present value, however, is the $35,000. 1 plus. So 0.5% becomes 0.005 to the power of 12. So my future value in this case power of 12. So the future value is going to be 37,158.72. So that's how much she's going to have if she chooses option A. Interest is paid at R%. What the hell does that even mean? Find the value of R in option B, given Nina the same future value after 1 year for option A. Give your answer correct to nearest 2 decimal places. So it's just simple interest. So the rate's going to be the same no matter what. So the simple interest formula, I is equal to PRN, and then the amount after that is equal to I plus P. So we need to work out what the interest is earned from this value from above. So interest just is equal to A minus P. So the interest earned is 37,158.72 minus 3,500, which is equal to 2,158.72. Okay, so that's the amount of interest they earn. So putting it back into this formula here, so the simple interest formula, it's going to give us what? 2158.72 is equal to, now the amount she started with, which is 35k, times R, we don't know. And now for the year, it doesn't matter because I think we have, yeah, per annum. So we're going to leave the n as 1. So n is equal to 1 because it's per year. So times 1. Okay, so again, that's just going to disappear. And then we just rearrange this. 2158.72 over 35k, and that's our that's our rate amount. So my rate is equal to, and I think they want it as a percentage as well, 2158.72 over 35,000. So it's equal to 0.06, and then as a percentage, well, we'll go 17 ... No, that's rounded. That's 3 significant figures. And so as a percentage, that is going to be 6.17%. Okay, so that's the interest rate if you go simple interest to get the same amount after 1 year. Oh, that's the end of the question. Okay. The price and the power consumption of 2 different brands television are shown. So we've got TV A, it's 900, 176 watts. TV B, 60 watts. The average cost of electricity is 25 cents per kilowatt hour. A particular family watches an average of 3 hours of television per day. I think we watch more. The annual cost of electricity for television A for this family is $48.18. For this family, what is the difference between annual cost of electricity between... So annual cost. So we're just looking at the annual cost to begin with. So 3 hours... So it's an average. So 3 hours per day, 365 days per week. So... I might be incredibly wrong with this. But... I believe that the power in A and B is represented by how many hours. So, like, for every hour. So, if you have the TV A on for 1 hour, it uses 176 watts, is my understanding. I haven't done this stuff in a very long time, so I can't remember. So... Okay, well, let's work out how many kilowatt hours I use. So, if that's a 1 watt per hour, so television A and television... Well, we don't need to know television A because we already know how much it costs. Television B, on the other hand, so kilowatt hours is equal to, and this is for television B, this is equal to 160 times 3 times 365, because it's the average of 3 days for 365 days of the year, and we want to know the annual price. So 160 times 3 times 365. So the amount of kilowatt hours is 175,200. Okay, and they use 25 cents per kilowatt hour. So times this by 0.25, and that should give us the amount of kilowatts or how much money it's going to cost them to run. 175,200 times 0.25. No, that's not right. Oh no, because that's in watt hours, isn't it? So kilowatt hours, it's going to be 175.2 times 0.25. So that's in watt hours, and that's in kilowatt hours. Yep, okay. That makes more sense. Again, if you get an answer that doesn't look correct, make sure you redo it. So oops. So it's $43.80. The annual cost of electricity for television A for the family. What is the difference in the annual cost of electricity between television A and B? So then the difference in A minus B. So television A was 48.18 minus B, which was 43.80. And we're going to plug that baby in. 48.18 minus 43.80. And we get 4.38. 4.38. So it's only a subtle difference. So the difference is $40. Difference is equal to $4.38. Okay. For this family, how many years will it take for the total cost of buying using television A to be equal to the total cost of buying television B? So essentially, we just need a difference of the two, divide that by the $4.38, and that's how many years it'll be till it sort of pays itself off. So it's $21.90. So cost diff. So 921, I think it was 80, wasn't it? 90, and that's just minus 900. Okay, and so we're going to do $21.90 divided by $4.38. So $21.90 divided by $4.38. Oh, 5 years. Exactly. So therefore, 5 years. The costs will be equal. So essentially, if they have so if they pay $21 more after 5 years, the amount will be equal. So like, realistically, a TV might last you 5 years, I guess. So I don't know. You could pretty much pick anyone and you'd save the same amount, really. You'd be paying the same amount, almost. It's almost negligible. Alright. Unless it was more kilowatt hours for more money. But you'd want something, like, beneficial from that. Anyway. Okay, so a salesperson is interested in the relationship between the number of bottles of lemonade sold per day and the number of hours of sunshine in the day. The diagram shows the data set used in the investigation of the least squares regression line. So there's the least squares regression line. It's like the line of best fit. It tries to fit as much as possible. Find the equation of the least squares regression line relating to the data set. Are we meant to use our calculator for that? I'm going to use my calculator for that, I think. So we're going to go into stats mode. Use an X and a Y. So my point is 2, 3, 5, 6, 9. And the Y values are 8. Let's say 11, 19, 22, and 30. So because they give you pretty much exact numbers, I think you have to use a calculator for this. So clear, shift 1, we're going to go to... I think we want 5. Now, I've got to remember how to do some calculator. So, the regression line. So R is the Pearson's correlation coefficient, and then A and B are just like the extra parts. So Y is equal to mx plus b, okay, or c, using the new syllabus. So we need a gradient which I believe is either A. Okay, what about B? (3.2). Yeah, okay, so it's going to be y is equal to 3.2x plus 2. Cool. Suppose on a 6-day point collected data which had 10 hours of sunshine on that day, 45 bottles of lemonade was sold, what would happen to the gradient found in part A? So what would we say? So 10 hours, 45. 10 hours. So it's going to be about here, so it's going to go up. So what would happen to the gradient found in part A? The gradient would increase. Because essentially it's going to be bigger than what the average is. So, because if we use this formula here, so y is equal to 3.2x plus 2, we substitute 10 in, so y is equal to 3.2 lots of 10 plus 2, so it's 32 plus 4, so y is equal to 34, okay? And because 45 is greater than 34, gradient's going to go up, okay? The gradient will increase because you're essentially adding something like a bigger point, and so to make the difference, it's going to like have to shift it up a little bit. Something like that. Okay, solve simple equation. Okay, so to get rid of this 2 on the bottom here, the easiest way for me to do that, x plus, so if we make that over 2, so 2x over 2 plus x minus 1 over 2, which we don't need to do, is equal to 18 over 2. Okay, then we can get rid of these guys, and we've got 2x plus x minus 1 is equal to 18. So that's 3x minus 1 is equal to 18. So 3x is equal to 19, so x is equal to 19 on 3. And just to check, 19 on 3 plus 19 on 3 minus 1 over 2 should be equal to 9. So we're going to try that. (19 on 3) plus 19 on 3 minus 1 over 2 should be equal to 9. It is. Beautiful. Cool. Easy peasy. Let's go next. Ariana owns 1,500 shares in the company. The market price for each share is $27. Ariana total dividend from these shares is $810. Oh, I don't know how to do these. 1,500 shares in a company. The market price for each share is $27. Ariana's total dividend from these shares is $810. Calculate dividend yield for her shares. Is there a formula sheet on the bottom of this? I've still got so much to go. This isn't telling me anything useful. No, it doesn't. Okay, cool. Cool. Alright, so I'm gonna have to just pretty much BS this one. Okay, so Ariana owns 1,500 shares in a company. The market price for each share is $27. Ariana's total dividend from the shares. Calculate the dividend yield for her shares. The market price for each share is $27. So I'm just going to write something and we're going to pretend that it's right. 1,500 times 27 So the yield, it's going to be 27 minus $26.46. Because I'm presuming yield just means how much they've made. I don't actually know myself. I'm just going to presume that's correct and move on. Whatever. Okay. Question 31. Present value interest. So you've got 300, 330, 360. Bank lends Martina 500,000 to purchase a home with interest charged at 1.5% per annum. She agrees to a loan by making equally monthly payments over a 30-year period. So 30, I think it's 360, isn't it? 30 times 12. Yep, so we're looking in this row. How much should the monthly payment be in order for her to pay the loan off in 30 years? Give your answer correct in nearest cent. So it's 1.5% per annum compounding monthly. So 1.5%, so 0.015 divided by 12 is 0.00125. So we're looking in this line here, okay? So this one and this one. So we're looking at this value here. So n, we'll just write down some working. So n is equal to 30 times 12, which is equal to 360. R is equal to 0.015 divided by 12, which is equal to 0.00125. Therefore, and I think it's like, is this how much she has to pay? Present value interest factors of an annuity table for $1 various interest rates given on this table. Interest rate per period is a decimal, and table of present value interest factors. The bank lends... Oh, no, because then we multiply this by this. Okay, I think from memory, it's been a long time since I've done questions like this. So if we do... Oh, hang on. No, it's the monthly payment, isn't it? So if we do 500k divided by... Actually, I wonder if it's just 500 divided by 289. 289.75411. Yeah, I think that's it. 289.75411. And so she needs to make monthly payments of 1,725 and 60 cents. Yeah, that seems right. Because then if you multiply that by 360, it's about, you know, like it's a bit more. Like not a lot more, but about 100k more. So that actually makes a lot of sense. The right angle triangle XYZ is cut out from a semicircle with the center O. The length of the diameter is 3016 and the angle in there is 30 centimeters, just straight on the diagram. Final length of XY. So this length here in centimeters corrected to decimal places. So it's trigonometry. We've got an adjacent and a hypotenuse, so it's cos. So cos 30 degrees equals to adjacent, so xy over 16. So xy is equal to 16 cos 30 degrees. We need to change this back to degrees. There we go. 13.86. centimeters. Cool, 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 cool. Hence, find the area of the shaded region in square centimeters. Correct to the nearest, so the shaded region. So it's going to be this triangle that we know nothing about its area from the semicircle. So we need to work out what the other side's going to be as well. So doing a quick calculation, we get that this is 8. Okay. So area of semi is equal to, so it's a half times the radius, which is 8, I guess you would say. Half times pi r squared, yeah. So half times pi times r squared, which is half times pi times 8 squared. Okay, so half times pi times 8 squared equals 32 pi, which I don't want in that, I want as 100.53. One decimal place, yep, 53 will do then. And then we'll round it down more when we get to the last bit. Okay, area triangle. So half times b times h. So half times 8 times, and then the other number, what was that again? 13.86. Okay. So half times 8 times 13.86. Okay, we get 55.44, and these are both in centimeters squared. So then the shaded area is equal to the area of the semi minus the area of the triangle. So 100 minus 53. 100.53 minus 55.44. Okay, put it in a calculator. I think it's 09, so it's what, 45.09? And just double check. 100.53 minus 5.44. 45.09. And that's centimeters squared. Okay. Correlation coefficient advice. By using the equation of the regression line, predict the average maximum daily temperature in Celsius for a town that is 540 meters above sea level. So my x is my 540. So y is equal to 29.2 minus 0.011 times 540. Okay, plug that in. .26. And that's going to be degrees Celsius, isn't it? Because that's the temperature. The gradient of the regression line is that. Interpret the value of this gradient in the given context. So the further above sea level the town, the colder it gets, i.e. for every 1 kilometer? 1 meter? More above sea level, the temperature drops by 0.011 degrees Celsius. Something like that. Okay. And the graph shows the relationship between the latitude x degrees south and the average maximum daily temperature for the same 17 hours as the regression line. Okay, so we've got this here, we've got this here. Another inland town in Australia is 540 meters above sea level. The latitude is 28 degrees south. Which measurement, height above sea level or latitude, would be better to use to predict this town's average maximum daily temperature? Give a reason for your answer. Oh dear, I hate these ones. It's only worth 1 mark. 540 meters above sea level, latitude is 28 degrees south. So 28 is about here. And then 540 would be 23. So 540 would mean that it'd be like somewhere over here. I'm going to say this one here because it's got a stronger correlation coefficient. So the latitude would be the more appropriate one. Appropriate predictor, as it has a stronger, although negative, correlation coefficient. Yeah, in this particular question, it's not actually asking you for your thoughts. It's saying, can you use the information to tell us why? Not like, oh, because, I'm going to use this one because I think it's more appropriate or blah, blah, blah. It's, you need to use this one because it has the stronger correlation coefficient. All right. Oops, that's not my number. There we go. Okay. Oh, this is the question apparently a lot of people were having issues with. In a park, the only animals are goannas and emus. Let x be the number of goannas and y be the number of emus. Yep, that makes sense. In total, okay, so well, that's pretty easy. So 4x plus 2y equal to 76. By writing another relevant equation and graphing both equations on the grid on the following page, find the number of goannas and the number of emus in the park. I'm going to solve this algebraically because I hate graphing, but I'm also going to graph it as well because it asks us to. But I'm going to solve it by doing simultaneous equations. 76, and then so 2x plus 2y is equal to 62. So that's equation 3, which is equal to 1 times 2, and we're going to do equation 2 minus equation 3. So 4x minus 2x is 2x, plus 0 is equal to 14. So there are 7 goannas. So x plus y equals 31. Sub into 1, we get 7 plus y is equal to 31. So y is equal to 24. So there are 7 goannas and 24 emus. Okay, so the 2 equations. So what we're going to do is going to rearrange. They probably gave you the space to rearrange the equations. So y is equal to minus x plus 31, and the other one. 2y is equal to 76 minus 4x. So y is equal to 35, 36, 37, 38 minus 2x. Okay, so minus x plus 31. So the first one starts at 31. And for every one it goes across, it goes one down. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 and 5, 5 and 5, etc. etc. Okay. And for the other one, it starts at 38, which is here. For every one it goes across, it goes 10 down. So 1 across, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So for every 5 across, it will go 10 down. 1 across, 2 down, 1 across, 2 down, 1 across, 2 down, 1 across, 2 down. Just 2 down, something like that. Okay, and so they're going to cross over somewhere in here. And lo and behold, so write in what these equations are. So this one was y is equal to 31 minus x, and this one was y is equal to 38 minus 2x. And that point of intersection here was at 7 and 24, it looks like. I'm just going to double check that from up here. And it is. Yeah, so 724. Cool. So number of goannas, 7, number of revenues is 24. And then the total, 24 is equal to 31, which is what we want. Okay, the publisher sells the book at $10. At the price, 5,000 copies of the book will be sold, and the revenue raised will be 5,000 times 10 is equal to 50,000. The publisher is considering increasing the price of the book. For every dollar price increase, the publisher will sell 50 fewer copies of the book. The graph of the quadratic model revenue is shown. By first finding a suitable value of X, find the price the publisher should charge for each book to maximize the revenue raised from the sales of the book. Wow. Wow, wow, wow. Okay, we can do speed. This bit's easy. So at x is equal to 0. Find the value to intercept the parabola with the vertical axis. So it's when x is equal to 0. I'm finding value for y. So it's this equation, or r in this case. So it's this equation here. So r is equal to, this is going to be annoying, negative 50x squared plus 4,500x plus 50k. Oh well, r is equal to minus 50, what's a 0 squared, plus 4,500, what's a 0, plus 50,000, and r is equal to 50,000. So that's pretty straightforward, that part. But by first finding a suitable value of x, find the price the publisher should charge for each book to maximize the revenue raised for the sales of the book. So it's between negative 10 and 100, okay? And so the peak is going to be halfway between those. So to do this without calculus is actually quite tricky. So, well, we just find a halfway point. So 100 minus 10 over 2, which is equal to 110 over 2, which is equal to 55? Yeah, 55. So it's the halfway point. So at x is equal to 55, peak of parabola as halfway point of 2 x-intercepts. Okay, now we just substitute that into the revenue formula. So r is equal to minus 50x squared plus, I think it was 4500, was it? Yep, 4500x plus 50,000. Okay, so r is equal to, so minus 50 is going to be 55 squared plus 4500 that's a 55. Wait, is r the value? Oh, and then we just divide that by, well, hang on. So publisher sells the book for $10. At this price, 5,000 copies of the books will be sold, and the revenue raised will be 5,000 times 10, which is 50,000. Publishers consider increasing the price of a book. For every dollar the price of the book is added is increased by the publisher. Okay, it's just really wordy. Okay, so plus 50,000, and then I've just got to divide it by the 5,000, I think, at the end. Okay, so minus 50 lots of 55 squared plus 4,500 lots of 55 plus. So he's going to make in revenue 146,250. I can't believe I still have 2 exams to do after this. Ugh. So that's the amount of revenue. So R from selling the books is. So if the publisher charges 10 plus X dollars from each book, quadratic model for the revenue raised R from selling the books is this. The graph which the quadratic model for a dashed line is used for values of X which are not relevant to the practical context of this problem. By finding a suitable value of X, find the price the publisher should charge for each book. Do I just need to substitute it into that? Oh my god, I just do, don't I? Oh, I'm an idiot. That's all I've got to do. Oh, that's so dumb. Alright, let's get rid of all that working out I just did. That's a time loss right there. Okay, so if it's X is equal to 55, and we've been told that the publisher charges 10 plus X dollars for each book at X is equal to 55, so charges just seems like a lot. X plus 10 at X is equal to 55, you should charge that's so much easier than what I was doing. Okay, whatever. Okay, project requires completion of 11 tasks A, B, C, all the way up to K. Network diagram shows the project given the completion time for each task in minutes as shown. Find a minimum time to complete this project. Oh, okay, so this is one of those minimum min starts max. Okay, so it's going to go, starts at 0, goes to 5 that way, it's going to go 8 that way. 5 plus 7 is, I believe 12, 14, 16, 7, so it possibly could be 17. But if I go this other way, I think I get 14. So 8 plus 6 is 14. Yep. Wait, no. The earliest starting time is when both of those things can be completed. So when both of the things are completed. So 17. So we can't go on from here until both of these, like this one here and this one here. So like until E and F are both done. So plus 5, 17, 18, 19, 20, 22, plus 6, 23. So 23 down here. So 26. Or 30. So it's going to be 30 for that one and then 40. Okay, now going backwards, we go 40, we go 30. Now coming up this way, it's got to be 22, and then coming down this way, it can be 27. And then I believe when we go back into 1, it's the... So it was the biggest going back, it's the smallest going forwards. So 21 or... So it's going to be 17. So 17 again. 15. 15 minus 7 is... Necessarily 15 minus 2 is 13. 30 minus 7 is 6. And then coming back down this way, 17 minus 6 is... Well, hang on. This doesn't make sense. Oh, because that's got to be 14, not 15. Okay, 14, 12, 5, 0. And then this way, it's going to be 17 minus 6, which is 11. Okay, so the point is that if I come down this path, this way, okay, the earliest you can start is at 0. Oh, well, if I do this bit here, the earliest I can start is at 8, but the latest time that I could possibly start doing B is at 11 minutes into the task. So 40 minutes. State the critical path for this project. So it's going to be A, C, D, E. A, C, D, E, G, J, K. And I think the way you're meant to represent this is A, C, D, E, G. So, critical path. Okay, new task X is to be added onto the project. The earliest starting time for X is 17 minutes and the latest starting time for X is 18 minutes. And X has a completion time of 12 minutes. Add task X to the given network diagram above and state the float time for this task. Well, the float time is 1. That's easy. Okay, so it's 17. And the latest time is 18. So if the latest time is 17, it's going to start here. And latest starting time is 18. So it's going to come across here. Like this. Okay, this is going to be task X. And task X, so for it to start at 18, So 17 to 30 would be 13. So it's going to be 12. Okay, because the difference between 30 and 18 is 12. Okay, a diagram shows a triangle ABC where AC is equal to 25, BC is equal to 16, ABC is equal to 28, and ABC is obtuse. Find the size of obtuse angle ABC correct to the nearest degree. So whatever it is going to be 180 minus that. Find the ABC. Okay, so we've got a cross, yeah, it's just a sine rule. So sine A over A equals sine B over B. So we don't know what this angle is, so we're calling it ABC. ABC over 25 equals sine B, which is 28. Over 16. Okay, so sine ABC is equal to 25 times sine 28 over 16. So angle ABC is going to be equal to sine inverse of 25 times sine 28 on 4. So angle ABC, if it was acute, it's going to be equal to, if I can get this on, sine. Oops. 25 sine 28 over 4 gives me a math error. I don't know where I wrote 4 because it's 16. That's weird. Just threw in a random 4 for no reason. Okay, so ABC is 47.18, or if we change it to degrees, minutes, and seconds, we get 47 to the nearest degree, so 47 degrees. Okay. Now for the obtuse part, it's 180 degrees minus 47 degrees. So it's going to be 153? No, 133? Yeah, 133 degrees. Cool, so that's the obtuse angle. So just 180 minus that. Because if you had the 47 degrees, like what that would look like, it would look like this, something like this. Right, something like that. Because we're looking for this angle in here. So we want the big boy version, which can happen, by the way. Okay, a random variable of non-positive distributed means 0. The probability given the value. Using the table shown that the probability, that a value from a random variable that is normally distributed with mean of 0 and standard deviation 1 is greater than 0.3 is equal to 0.3. Oh, I've got no idea what this is even saying. Okay, random variable is normally distributed with mean 0 and standard deviation 1. The table gives the probability that this random variable lies between 0 and x and z. Values of z. The probability values given in a table for different values of z are represented by the shaded area of the diagram. Okay, so between 0, so say it's between 0 and 0.1, so like here, then you'd have this value here. Okay, that makes sense. Yeah. Using the table, show that the probability Show that the probability that a value from a random variable that is normally distributed with a mean of 0 and a standard deviation of 1 is greater than 0.3 is equal to 38.21. So it's greater than this. That last sentence actually makes no sense. This is looking like it might be a good split. Yeah, I'm thinking the same thing too. Hey, I've still got an hour to go before I hit it. And I don't have any questions to go. 2, 3, 4, 5. I've got 5 questions to go, so it's going to be pretty good. I'm going to quickly duck out and grab a drink though after I do this paper. And then the real fun's going to begin. So random variable is normally distributed with a mean of 0. That last sentence. With a mean 0 and standard deviation 1 is greater than 0.3 is equal to 0.3821. Is greater than 0.3 is equal to 0.3821. Okay, I think it just means to show that it's equal to this. Because if you are looking between, so Z score between -1 and 1 is equal to 68%, I'm pretty sure. No, that can't be right. A random variable is normally distributed with a mean 0 and a standard deviation 1. The table gives the probability that the random variable lies between 0 and z for different values of z. The probability values in the table for different values of z are represented by the shaded area in the following diagram. Using the table, show that the probability that the value from a random variable that is normally distributed and mean 0 and standard deviation 1 is greater than 0.3 is greater than 0.3. I just don't understand what this question is asking. Using the table, show that the probability that the value from a random variable that is normally distributed with a mean 0 and a standard deviation 1 is greater than 0.3 is equal to 0.3821. The hell does that even mean? Well, let's just keep going down this road of thought. 0.68. Okay, so half of that, so from 0 to 1, it's going to be 34, isn't it? Which is greater than 0.3. Is equal to 0.3821. I just don't understand what the hell this bit here means. Is equal to 0.3821. Alright, I'm just going to leave it at that because I've shown that it's greater than 0.3. I just don't understand that last bit. I'm going to have a look at the solutions when they put them up. Because that's really, really weird and I've spent way too long on that. Okay, birth weights are normally distributed with a mean of 3300 grams and a standard deviation of 570 grams. By first calculating a Z-score, find how many babies out of 1,000 are expected to have baby weight greater than 3471 grams. Okay, so 3471? By first calculating a Z-score, find how many babies out of 1,000 with a standard deviation of 5,700. So, greater than 3471. So if it's the standard deviation is 5,700, I suppose we can work out like what points they're going to be. So 3300 3471 minus that gives us 171. Okay. 171 out of 5.70, or 570, and this should give us, actually if we do it the other way around, this should give us what point it is. So 171 out of 570 is going to give us 0.3. Okay, so this guy here, this 0.3 would give a probability of 0.1178. Gives a probability of 0.1178. I think it was a 9 actually. Yeah, it was a 9. Okay. So we're looking for the greater than that, yeah? So from 0 to 0.1179, so up to that value, because remember the whole bell curve is 100%. So if this whole thing, okay, so the whole thing is 100%, I know from the center to this bit here is 0.1179. I know that this bit here is 50%. So up to 0.3 standard deviations is equal to, or 0.3 Z-score, up to, why would you do this to me right now? Up to an 0.3 Z-score, you'd have 0.5 plus 0.1179. So it's 0.6179. Okay, so to have it greater than that, so by first calculating Z-score, find how many babies out of 1,000 born are expected to have a birth weight greater than 3,471. So if we go 1 minus, I'll do it down here. So 1 minus 0.6179. So this is babies. Three, four, seven, 1. Okay, so 1 minus 0.6179 equals 0.3821. So therefore, total babies above that 3471 grams is going to be 1,000 times 0.3821. So it's going to be below that line. Therefore, 382 babies. Okay, there we go. Oh, that was a mess. Alright, the diagram shows a compass radial survey from the field ABCD. Triangle COB has an area of 466 meters squared. Okay, so that's that one there. Find the size of acute angle COB. Correct to the nearest degree. Okay. Ow. So it's 150 to here. Okay, so they've conveniently left that one off, otherwise that'd make it very easy. So this angle in here from 330 to 80, so it's going to be 30 degrees. Plus 80, so it's 120. In here it's going to be 80 to 150, which is 70 degrees. So 120 to 70. And we don't know anything about that other bit. That other bit. Okay, we can work out what this angle is in here by using the cosine rule. Can we? No, because we need the third side to do that. Ding, 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 ding. Half ABC sine. Find the size of the acute angle COB, correct to the nearest degree. COB. So we're looking for this angle in here. If we knew what this length was, we could do it quite easily. If we knew what this one was, we could do it quite easily. But this problem's pretty much just the same as this problem here. Actually, we can use the area formula. A is equal to half AB sine C. Because we know what the area is and we know what A and B are. And we're trying to find what C is. Cool. Okay, so area is 466. Equals to a half times A, which is 28. Times 35. Times sine C. Okay, so we're going to divide 466 by all those things. So 466 divided by 0.5. Divided by 28. Divide by 28 and divide by 35. And that's going to give us 0.951 is equal to sine C. So C is equal to the inverse sine of 0.951. So C is equal to pretty much 72 degrees. Cool. A farmer wants to put a fence around the triangle DOC. Find the length of fencing required. Give your answer in meters correct to one decimal place. It's this one, isn't it? Okay, well, we know what this is now. We know that this is 72 degrees in here. And so we can work out what this angle is in here. Then we can use the cosine rule, and then we can just add them all up. Cool. Okay, so my angle theta in this case is going to be equal to... So it's 360 minus those. So 120, 70, 72... Okay, let's do it in here to be quick. 360 minus 70 minus 72 minus 120 equals 98. Okay, then we can use the cosine rule. So cosine rule, so c squared is equal to a squared plus b squared minus 2ab cos c. So c is equal to the square root of all this. Okay, so A is 28 to 31. 28 squared plus 31 squared minus 2 times 28 times 31 times cos of the angle, which is theta, which is 98 degrees. Which makes me think I'm going to have to do not 98, but 82. Anyway, we'll do this first. 28 squared plus 31 squared minus 2 times 28 times 31 times cos 98 degrees. And so we get 44.57. How many decimal places do they want? Corrected one decimal place. So C equals 44.57. So therefore Peruna equals 44.57. And I think it was just around that. DOC. DOC, yep, cool. Plus 31 plus 28. And that's going to give us $103.57, blah 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 blah, which is equal to 103.6 meters. Yep, cool. And so that's how much meters of fencing he needs. So finish it off. He needs 103.6 meters of fencing. Cool. Alright, a table of future values. Cool. Simon deposits $1,000 into a savings. It's for $1. Cool. And end of each year for 8 years. Okay, 8 years, 0.75% per annum, so we're looking at this guy in here, compounded annually. After the 8th deposit, Simon stops making deposits, but leaves the money in the savings account. The money in her. Oh, actually. Yeah, okay, so 1,000 times 8.2132, which is equal to whatever that is. And then you do compound interest formula for the other one. So $8,213.02. So if you just did the normal one, so if he wasn't putting $1,000 in each time, you would just use the regular compound interest formula. Okay, so that's for the 8 years. And then for the 2 years, we're going to do A is equal to P1 plus R to the power of N. The principal amount, so the amount he starts off with in that time period is this. The rate is 0.0125 for 2 years. Oh. So then, at the end of the 10 years, 8419.8 81. Yeah, that makes more sense. So at the end of 10 years, he will make, or he'll, yeah, make do 8419.81. Okay, after this question, we're done with standard. 40 minutes to go. In a particular city, the heights of adult females and the heights of adult males are each normally distributed. Information relating the two females from the given gender from table 1. This means the standard deviation of adult females and males in centimeters are given in table 2. The selected male is taller than 84% of the population of adult males in this city. By first labeling the normal distribution curve below with the heights of the two females given in table 1, calculate the height of the selected male in centimeters, correct 2 decimal places. Whew. Okay, so percentage of females in this city shorter than this person. So shorter to the left, taller to the right. So 97.5 is 2.5%, so it's 95, so that's person 2. So 0, 1, 2, 3, -1, -2. So this is where person 1 is. So it's going to be, I should probably do this way. So it's 175, so this is person, or female 1 I should say. Female 1. 160.6 and 16%. Oh, I don't know whereabouts that would sit. Whereabouts does 16% sit? Let me think. So 16%. It's the center, 64. So what's back this way? So 64 add 16. Subtract 16 I should say, so it's going to be 4, it's going to be 34%. Then we go to 95. So it's going to be 5%. And so it's somewhere in here. Female 2. So at 106. So 106.6 goes there. Oh, 160.6. Okay, so 160.6 goes there, and that's female 2. Okay. So I've put those two girls on there, the two females on there. Is there like a table for this? These numbers are ridiculous. Selects a male, store 84% of the population of top males in this city. 16% is such a stupid number to use. See, 97.5 makes sense. Because it's 2.5. Wait, no. That's not even right. 97.5 is like bigger than this. Christ, I've got no freaking idea. So, can we relate it back to a z-score? No. I don't think so. Where are the z-scores? So, x minus mu over sigma. See, look, this is all we've been given about this. Like, no table, no nothing. X minus mu over sigma. So she's going to be bigger than that.